This optimization problem is a little bit easier compared to the others. So the setup is easy. We have one function or equation y equals to the square root of x plus 3. Here is the graph. It starts at -3, 0. Because of the plus 3, you shift the point, the starting point from 0, 0 to -3. The plus 3 means shift the square root function 3 units to the left. And then the square root function is an increasing function. As x goes up, y goes up, and this is above the x-axis because the square root produces 0 or past it. All right, so that is the graph. The question is asking which point. There is a point x comma y somewhere on the curve, and this point has the closest distance to the origin. I want you to find the point. So which point on the curve? Tell me the coordinate such that the distance between that point and the origin is at the minimum. All right, so since we are talking about distance, we have to recall the distance formula. We have 2 points, x1, y1, x2, y2. The distance between them is y2 minus y1 square plus x2 minus x1 square, and then you take the square root of that. So the 2 points we have the origin, and the other point is just you plug in x. That is what you get for the y. And then, of course, when your instructor put this on the exam, they can always change the problem a little bit. Instead of the origin, they can just give you a random point, like let's say 2, 1, 3, 2, so on and so forth. Right? They can always change that point. But we use 0, 0 to make the math cleaner and easier. Okay, let's set up the primary function. So the primary function, there is no secondary function. We only have one primary in this problem. So that is d. I'm not going to do d of x because I want to make sure that the function is in terms of one variable. y2 minus y1, so that will be the square root of x plus 3 minus 0 square x2 minus x1, that will be x minus 0, and then square. All right, okay, so what is next step? So next step, let's just continue right over here, and then before we do so, this is in terms of one variable, so I am going to call this a d of x. So, and then this one, the square root, so that is gone, right? So we have x plus 3 and then plus x squared. So that is our primary function. So this is primary function, and there is no secondary. We are going to focusing on this distance formula. All right, so you are looking for the minimum distance, so you have to take the derivative. So d prime of x, that is equals to 1/2. We have x plus 3 plus x squared to the negative 1/2. By chain rule, you take the derivative of the radicand, which is 1 plus 2x by chain rule. So this is a chain rule. Let's just drop a note over there so you know what you did. And then you have to set that equals to 0, right? So set that equals to 0 for a minimum distance. So we are looking for slope decreasing, slope 0, and then slope increasing to get a minimum. Okay, so before we do that, let's rewrite the derivative. So as 1 plus 2x divided by 2, and then the square root of x plus 3 plus x squared, and then we set that equals to 0. So basically all you have to do is you multiply the denominator on both sides, or you can think about that as the numerator divided by denominator equals to 0. The only way to make a 0 is you have the numerator equals to 0. So as a result, x is equals to negative 1/2, and this is the only critical point. Now, when you prove the critical point is a minimum, there are two ways to do it. Either you use the test interval, test value to prove the slope is decreasing, 0 and increasing, or you use the second derivative test. I do not prefer using the second derivative test because the first derivative is pretty complicated. So if you go to the second derivative test, you will have to do a quotient rule. So in this case, I don't prefer using a second derivative test. But in some problem, the second derivative is easy. So in that case, I prefer going through the second derivative test. So this is the only critical point. But before you draw your test interval, you have to be aware that the domain of y. Do you still remember that we have y equals to this, y equals to x plus 3, and the problem is based on this. You have to tell me what the domain is, because you don't want to accidentally pick a test value that is not inside the domain, right? You don't want to pick a test value where x equals to -4 or -5, because that is not even inside the domain. Okay, so this domain x plus 3 must be greater than or equal to 0, so x must be greater than or equal to -3. So that's why you see that on the picture. Okay, so when you include this and the critical point, so here is your test interval. Let me change the color. So your test interval, let's pick a red. And then here is your test interval. You want to put a -3 in here and then block the rest, so you don't accidentally pick any number on that side. And then you have a -1/2. And then the maximum, I won't waste time to find the maximum. So this is just from -3 to -1/2. And then from -1/2 to positive infinity. The positive infinity doesn't change the game. So this one, pick something easy. I will just pick x equals to 0, the test value. The intervals are test intervals, so pick x equals to 0, and then this pick x equals to -1. This is x equals to -0.5, so -1 is between them. And then you do the plug-in, so you have d prime of -1, so you just plug it into the function. So you have 1 plus 2 times -1. And then the denominator, I don't care what it is, the denominator is guaranteed positive. 2 times -1 plus 3, and then plus 1. That is guaranteed positive. The top is 1 minus 2, so that is negative. And then how about d prime of 0? So you have 1 plus 0, and then 2, 0 plus 3 plus 0. The bottom is guaranteed positive, the top is positive. That makes the whole thing positive, so we have a derivative negative, so that is decreasing. That is decreasing, and then this one is increasing. As a result, we have decreasing, increasing, so x equals to -1/2. That gives me a minimum at x equals to -1/2. So what is your conclusion? Let's draw a conclusion. So to save myself a little bit space, I'm going to move this up a little bit, and then for the conclusion, let's use a different color to do that. Let's use a green. So the conclusion is I want to let x equals to -1/2. So what is y equal to? Y is equals to -1/2 plus 3. So you have a -5/2. 5/2. So that is equals to square root of 2.5. So the point is x is equals to -1/2. Y is equals to 2.5 to get the minimum distance. All right. And then what is the minimum distance? Can you go one step deeper than that? Basically, the problem is done, the job is done. But what is the minimum distance? Okay, let's dive a little bit more to the problem. So we have a 0, 0. We have a -1/2, and then a square root of 2.5. So the distance is equals to y2 minus y1, so we have square root 2.5 minus 0 square, and then plus -1/2 minus 0 square. So that is what is that equal to? That is equals to 2.5, and then that becomes 1/4, right? So 1/4, which is 0.25, 0. I'll just write 1/4. So this one, that is approximately equals to 1.66. This is the minimum distance. And then if you consider the origin 0, 0, and the starting point -3, 0, this one we don't need to run the distance formula. The distance between this is 3 units. Is 3 units. So this one is actually smaller. Alright, so that is the end of this video. If you like the way I explain this stuff, give me a like, share, and subscribe, and I will see you all in the next problem. Signing out.